All right, so I don't need the loft just yet, I don't think. Actually, I will soon. Anyway, so what I am going to do next is to actually rotate it. So the rotation is going to be something that you obviously know about, but we're going to use a slightly different kind of rotate. Um, Go up to the Transform tab under the Euclidean panel. Here are those four different types of rotates. So if you read the descriptions, you can rotate an object around an axis, but look very closely at the icon. It's a point and a red line in between, which means that you could drop it in and read the description of what the input is, but this means that it's going to ask you for a line or a curve as the establishment of the axis. Rotate 3D will do pretty much exactly the same thing, except it's going to request a vector, which is kind of a magnitudeless orientation in space. And then rotating an object in a plane, and then obviously rotate object in a plane. Those ones just operate a little bit differently about how you establish what the plane is. The one we want here is rotate axis. Now rotate axis, this is again under Transform Euclidean. Now rotate axis is going to ask for the geometry, the angle in radians again, and the axis curve or line. So it's pretty self-explanatory, I think, at this point, right? We have, except the only part that's not self-explanatory is what exactly are we going to rotate. I've created, if I turn that off, I've created two curves. If I turn it on, you can see that I lofted those two curves. If I tried to rotate the surface, that technically would work, but what I really want to do is set up a construct based on curves and let the creation of the surface be the byproduct. So I'm going to turn this off for now so that you can just kind of visually see how it's going to be structured, and rotate the line, the second line that I made. So that's going to be my geometry. And the axis is going to be the base curve. All right, so I'm going to plug that in. And what I want to do is change the rotation, right, based on the same thing that you see all the time when we're doing rotations here. I'm going to say, except, actually, we're no longer going to rotate by 360 degrees. If it's a piece of paper and it sits in the vertical plane, you technically have a maximum of 180 degrees to fold it down, or if I want to go the other way, negative 180 degrees. So those would be your limits, negative 180 to 180. Does that make sense? Why? No? So I'll draw it on the board. All right. He said no.
He said no?
We've got to know. Yeah, we've got to know. We've got to know. No child left behind, right? That's a joke. All right. Okay. So, you know that from your origin point on the Cartesian coordinate plane, usually when you're dealing with it in math class, right, the convention is to say this is 0, right? If you set an angle to or a line at an angle of 0, it goes off to the right. If you increase the angle, then it rotates counterclockwise up to here, which is 90, and then 180 and 270. Right, so the rotation goes counterclockwise. If we have a piece of paper that, rather than looking at it in the horizontal plane, like this, it sits in the vertical plane, then our rotation, if we set our base point, well, I'll just get rid of this bottom half for you. if our base point for the rotation is there, right, the bottom of the piece of paper, and our top of the piece of paper is up here, then the switch is that this is no longer 90, it's 0. Because we've changed the convention to say we're now looking at it as a vertical piece of paper rather than a horizontal one. And so what that means is if we break it halfway, or if we wanted to rotate it one way versus the other with a maximum rotation, right? So if I wanted to fold it just from this base point, then my negative rotation would only go to 90, because you can't go underground. And it would only go to positive 90 on the other side. If I fold it in half, and this is my basis of rotation, then I can go around to here, which is a half circle, which is 180 degrees. So negative 180 and positive 180. Okay? I'm sure that helped out some of your classmates too, so don't feel bad that you were the only one that spoke up. You were not the only one that didn't know it, I'm sure. So our rotation here then is going to be to set a minimum and maximum value. So now I've kind of rethought what my maximums are, and I think really my maximum is going to be 90 degrees. But that doesn't really help me very much, because if I go all the way 90 degrees, then I might as well have just created it in that plane anyway. So I'll set a smaller margin, say negative 15 degrees and positive 15 degrees. So our slider is going to be negative 15 to 0 to 15. So negative 15, 0 I'm going to start at, and 15. Under math and trig, we can pull in radians again. And now what you'll see is that we have our original curve, which is going to remain, and our new curve. And if I slide back and forth, let me kind of get it into plane so you can see what's really happening. So slightly off axis there so you can see it. We will be able to rotate now to negative 15 degrees that way and positive 15 degrees this way. See how that's working? So now the real kicker is with this curve, right, that's not connected to my rotation. So if I truly want to fold the plane, I need to disconnect my top curve, which is that, and connect my rotated curve, which is this. And now that surface is going to rotate positive and negative. Okay. Are there any questions about that so far?
Your rotate axis, the A, or sorry, the X, what's that connected to?
The X is connected to the original line, the line down the bottom, the curve that we created. It would be 90 degrees if you wanted to go all the way down.
All the way down?
Yeah, I'll show you real quick. So negative 90, less than 90.
Oh yeah, it's going to be 90.
So that's negative 90, goes all the way up to 0, and then all the way down to 90. All right. Get rid of that. Okay, so I'm going to stop this video here and then continue on with actually establishing our top curve rotation adjustment, and then we're going to create the next plane that actually grows off of that.